Alright, so we're going to come back to the continuing coverage of the walkthrough series, and in this episode we're going to be looking at 9618 variant 4.2 of May, June 2023, and we are doing the Python implementation for question number 2. So let's go ahead and look at the question here. It says that a business sells a single product. Customers can purchase one or more of this product. Each sale has an ID and a quantity, for example, A, B, C, and 2. So A, B, C, D is the ID and 2 is the quantity there. The business needs a program to store the data about the sales in a circular queue data structure. So our first task is to write program code to declare a record structure that's called sale data to store the data about each cell. So let's go ahead and look at that right here. So I have the class definition, or rather a class definition I should say, for a custom record structure that's going to be called sale data. So it's important to realize that in Python, there's actually no record structure that you can declare or that you can make use of that is built into the language, as it were. So the nearest thing that you can use to a custom record like what we do in pseudocode is to make use of a class. So essentially, we are going to define a class that's called sale data, as it were. So on line 4, we have the class definition, sale data. Then on lines 5 through 7, we actually have the constructor for this particular class. So we know that it needs two identifiers, or rather it needs two attributes. Sorry, not identifiers. It needs two attributes, the ID and the quantity, as it were. So you actually see that for the constructor, we have the sale ID, which is going to be of type string, and the quantity, which is going to be -1. And then I did initialize these, or I did give these an initial value of an empty string and an integer of -1, just for a start. But of course, you actually don't need to give them initial values. You can just set them as they are, and you'd still get full marks for it. So you can go ahead and copy the code and paste it inside of the evidence document. Then coming back to part B, we are to write program code to declare a global array that's called circular queue of 5 items to store the sale records. We are going to declare the global pointers head and tail, so that's two variables there. Then we are going to declare the global variable that's called number of items. Then we are also going to initialize all the elements of the circular queue to an empty record where the ID is now and the quantity is -1. Then we are also going to initialize the head, tail, and number of items to 0. So remember earlier on I did say that you actually don't need to change to have this empty string going on and this minus sign going on, rather this -1 going on for your quantity. But now when you get to this part of the question, you would realize that instead of having to initialize or to use a loop to initialize the values to an empty string and a -1, you would then have to come back to the constructor and just set the starting string to an empty, the sale ID rather, to an empty string, and the quantity to -1. So by doing this, it means that any object that we instantiate of type sale data, because the constructor is setting them to an empty string and -1 respectively for the sale data and rather for the sale ID and the quantity, it means that any object we instantiate of this particular instance, it's going to have those attributes there. So that's the reason why you might want to come back and do it inside of the constructor, as it were. But of course, you don't have to do that. You can always use a loop to initialize these values to an empty string and -1 respectively. Yeah, then for the size, you see that I have the size is a global. Wait, where is it? We have a size of 5 that we are required to declare for the circular queue, is it? So I'm actually using a constant called size right here. Then my circular queue is going to hold objects of sale data type. So in this instance, we are now calling the sale data constructor, as it were. So it's going to initialize an object of type sale data in the range of size, and size is 5. So again, we are using list comprehensions in this case, just as we did. If you did see the video for question 1, we also used list comprehensions. So list comprehensions are quite powerful, especially if you need to initialize your lists with preset values, as it were. So we have a list comprehension going on, and it's simply going to declare a list or an array that's going to hold 5 objects inside of this circular queue data structure, as it were. Then for the head, the tail, and number of items, we are supposed to initialize them to 0. So we've done that right there. So having done this, we can safely go ahead and copy the code and paste it inside of the evidence document, as it were. Then looking at part C, we have a function called enqueue, and it's going to take a new record as a parameter. It's going to insert the record in the circular queue at the element pointed by the tail, pointed to by the tail rather. It's going to update pointers and other variables as required. Then it's going to return -1 if the circular queue is full, and then it returns 1 if the record is stored successfully, is it? So we are to implement the functionality for the enqueue method right there. So I have that going on right here, and you see that I'm also using annotations for this particular function, as it were. So on line number 18, we have the function definition. It's going to take a new record. We just call it a new record variable right there. Then it's of type cell data, because that's what they want us here to do. Then it's going to return an integer, so it's -1 if we are unsuccessful, then 1 if we are able to put the item into the circular queue, as it were. Then on line number 19, of course, we're having a doc string that's just describing what the function does, but it's not really needed. Then on line number 20, we have that we are making reference to the global tail and number items, because we have declared them outside of any function right here. So for this function to be able to recognize these variables right here, we have to use the global keyword first, then specify the variables, the variables rather, that we want the function to recognize. Then on line number 21, we're checking to see if the number of items is equal to the max to the size of our queue, which is currently 5, or which is 5. Then if that's the case, then it means that the queue is full, so we cannot enqueue anything into the queue, as it were. Then if we have space, we are going to take the new record that we were passed as an argument and store it at the current position that is being pointed at by the tail pointer right there inside of our circular queue, as it were. Then right here, we're actually doing something that's a bit clever, or that's clever if I should say, especially for circular queues. While this notation might seem strange, we are essentially wrapping around the tail, because the circular queue is going to be connected at the head to the tail. So you can think of a complete circle or a ring, as it were. So when you enqueue something, you need to update the values, or to push the values, as it were. So I actually have a separate video entirely on my right here on my channel, where I go into more detail behind the logic of a circular queue, specifically when it comes to enqueuing and dequeuing elements into a circular queue. So I would encourage that you check that out, so you actually get to have a visual representation of what I'm trying to explain right here. But essentially, we are just wrapping around the indexes or the indices, as it were. Then of course, since we enqueued an item onto the queue, we have to increment the number of items by 1. So we are using the shorthand notation. Instead of having to say number of items is equals to number of items plus 1, we can just go and say number of items plus equal to 1. Then it's going to increment number of items. Then of course, we return 1 to show that we were able to enqueue the given record, as it were. So having done that, you can go ahead and copy the code and paste it inside of the evidence document. Then moving on to the next aspect here, we have the function called dequeue. Essentially, this removes an element or a record from the queue, as it were. So it's going to return a null or empty record if the circular queue is empty. Then it's going to return the first record in the queue if the circular queue is not empty. Then it's also going to update the pointers and other variables as required. So let's go ahead and look at the implementation that I have going on here. So as before, this is a void function, so it doesn't take any parameters. Rather, it doesn't take any parameters, is it? But it's going to return an object of type cell data. So that's what we are annotating here, that this function is going to return a cell data object. Then of course, we have the doc string explaining what the function does right there. You could actually omit it if you don't want to include it. Then here we are telling the Python interpreter that we are making reference to the global head and number items variables that we declared right there on lines 13 and 15. Then we are checking to see if the number of items is currently equal to 0, in which case it means that we do not have anything. So we just return an empty cell data object, as it were. And remember, we did initialize the cell data object to an empty string and -1 for the quantity. So that's essentially what is required right here to return a null or an empty record. So here we are returning an empty record if the number of items is currently 0. Otherwise, we proceed to take the current element that is in the circular queue, which is being pointed to by the head pointer, and we store that inside of this record variable there. Then we also have to replace where we removed the particular record that we just pulled out from the circular queue, as it were. So we need to replace that with a now or with an empty record object. So that's what we're actually doing on line 35. So remember, whenever you instantiate a cell data object, it's going to be a now object, is it? So we are now putting that in the place where we just removed the record right there on line 34. Then right here we are now wrapping the indexes or the indices, as it were, around the circular queue, or to update the indices, since we just put something out of the circular queue. Again, I would refer you back to my animated series. I have an animation of the circular queue where I explain it visually how this operation of saying head plus modulo size works. I would encourage that you check that out if you don't really understand what's going on right here. Then on line number 37, we are decrementing the number of items by 1, because since we removed an element from the circular queue, we have to decrement the count for number of items. Then eventually we are going to return the object that we just pulled right there on line 34 there. So having done that, you can go ahead and copy the code and paste it inside of the evidence document. Then for part E, we have this function code, rather this procedure code, enter record, and it's going to take an ID and quantity as input and creates a cell record. Uses enqueue to insert the record in the circular queue, makes sense. Outputs full if the record was not inserted in the circular queue, and outputs stored if the record was inserted in the circular queue. So we have to write program code for enter record, as it were. So coming down to line 41 through 48, that's where I have my enter record function going on. So I'm using annotations to describe what data type is cell ID and what data type is quantity. So you can see cell ID is going to be a string and quantity is going to be an integer. Then of course we have a doc string going on there. I'm going to ignore it. Then on line 43, we are now instantiating an object of type cell record. So we are going to be using the parameters that were supplied by the user to instantiate that particular record entity or object, as it were. Then on line number 24, if we are able to enqueue record, then we are going to return a value of 1, is it? Then if we are unable to enqueue the particular record, you remember that we return -1. So in the case that result is going to be -1, so remember when this enqueue function returns something, we are storing it inside of this result variable right there. So depending on whether result is 1 or -1, that's what we are going to test out on lines 45 through 48. So if the value of result is 1, then we print the queue is full. Otherwise, we are going to print the value, or rather the record is being inserted into the circular queue, as it were. So this is the implementation for the enter record function or procedure. So you'd go ahead and copy this code and paste it inside of the evidence document. Then moving on to F, we are given those cell records that need to be entered into the program. So we have the ID and the quantity for each of the respective 6 records. So we are to amend the main program to use enter record to insert the 6 records in the table, these ones. Then we are going to use dequeue to remove 1 record. So maybe let me do this step by step so you can actually see everything in more detail, or rather you can understand everything. So we are to use enter record to input the 6 records in this table. So I'll come to the code right here, scroll down to my main method. So you see that we are now using, or we are now calling the enter record function that we just declared in the previous part of the question. And we are passing the arguments that are inside of this table. Yes, so you see that ADF, the quantity is 10, OOP, the quantity is 1, and so forth and so on. So we are just taking the ID and the associated quantity and passing them as parameters to the enter record function, as it were. So we do this for all the 6 entries. So that satisfies this part of the question right here. Then the next part requires us to use dequeue to remove 1 record. So we dequeue an element. Then remember, dequeue is actually going to return an element, as it were. So we are going to store that element inside of removed. Then output either the ID and quantity of the removed record or an error message if the circular queue is empty. So since we dequeued something and stored it inside of this removed variable right there, we are going to check to see if the ID of removed is equal to an empty string. So in which case it means that the queue is empty, because only a now object or an empty object, or rather an empty record, would have an ID of an empty string, and we did define that earlier on in our constructor right here. So that's why we are checking to see if the ID is equal to an empty string. It means that the queue is empty. Otherwise, we are simply going to print the ID of the removed record as well as the quantity, as it were. Then we are going to use enter record to input the record with ID LLP for a second time, so which is this one right here. So right here we are going to call enter record and pass LLP and 3 again as parameters right there. Then we are to output the ID and quantity for all the records currently stored in the array. So here we are making use of a for loop that's going to iterate through the circular queue data structure, and we're checking to see if the cell ID is not equal to an empty string. It means that definitely we have an object in that place, so we simply output the object, as it were, that is the object's cell ID as well as the cell quantity, as it were. Then the last thing is for us to test our program and take a screenshot of the output. So let me just go ahead and pull up the terminal real quick, play the console. Then the name of my file is actually question2. So there we go. So you see the output for our program. So we have successfully stored the 5 elements. Then the 6th element wasn't stored because the circular queue is full. Then we remove ADF. Then we store LLP. Then we output the contents of the circular queue, as it were. So having done this, you can go ahead and take a screenshot of your output and paste it inside of the evidence document. So yeah, that's just about it for this episode. I'll see you in the next one.